Hey guys, we're looking at Integrated Math 2B, 1.4b, inverse trig ratios. This is lesson 4 of 4 for trig ratios. All right, so I've got this warm up for you guys. Because this is a recording, I encourage you to pause the video, try this on your own, and then I'll go over the answer in just a moment. All right, so go ahead and click pause, try this one on your own. Okay, assuming you have paused the video and you have your work, you're ready to check, we'll go over it. All right, so it's saying find the sign of, and this is a new symbol. I don't think we've seen this yet. This is just called beta, like a beta fish, beta. This is another just Greek symbol, right? Like theta, a lot of etas. Theta, beta, there's also alpha, which looks like that, but anyhow, beta, just an unknown, we just use this for an unknown angle measurement. All right, so we want to find sine of this angle. All right, so sine of now beta, what is our ratio going to be? Right, sine is SOHCAHTOA. We're asked to find the trig ratio. Because the sine so opposite over hypotenuse is what we're going to be looking for. So we're always going to start with annotating our figure before we dive in, right? Imagining, if you will, that we have a flashlight and we are in the corner of B. We're like pressing that corner. We've got our flashlight. We're shining the light across. This is going to be where the light will shine. You guys can agree? You can see, visualize that. So if we've got our flashlight, we're shining it from that corner. This is going to be the opposite side from that angle, from that corner. Hypotenuse is always directly across from the 90-degree angle. It's also, remember, always our longest side length. So if you're not really sure, right, 8, 15, or 17, 17 is going to be the hypotenuse because it's the longest side length. And that's it. We don't really care about, not that we don't care about adjacent, but we don't need it, so we don't need it. So sine of beta is equal to the opposite 15 divided by the hypotenuse 17. So if you also had D for your answer for this warm-up, pat back. Very nice. Nicely done. All right, we're going to jump in for our notes. Again, this is a recording, so it's a little difficult to have a discussion, but I wanted you to look over this problem. What do you notice about this problem? Maybe what's different about this problem versus the last one. So again, I encourage you to pause the video, look this over. What's going on in this problem? What do you notice? All right, assuming you have stopped the video, you've got your observations. Let's see. So first of all, I noticed there is a question mark here for this angle, right? Normally it's theta or now beta. Now it's just a question mark. And they also did not give us the hypotenuse. Oh my goodness, isn't that interesting? So let's see what's happening here. So before we dive in for our as a class, I've got this problem here. Can you give an example of an inverse operation? So for example, like the inverse of an exponent. So inverse operation, this is again how to cancel it out if we're looking at equation. Inverse, does that ring a bell? Inverse. This is a recording, so I don't know what you guys are saying. So inverse operation, right? Like addition, the inverse would be subtraction. For multiplication, the inverse is division. For this example, an exponent, the inverse is a radical, right? So if it's an exponent of 2, the inverse is a square root symbol. Okay, so inverse is just doing the opposite operation. All right, click share, and let's keep rolling. All right, we're now on slide 4. So very similar, inverse. We see this happening with trig functions. All right, so this is our just standard SOHCAHTOA. I'm going to write this out to SOHCAHTOA. All right. And what's happening here? So our goal before, when we're using SOHCAHTOA, it's to find the ratio, right? Opposite over hypotenuse, opposite over adjacent, adjacent over hypotenuse, right? We're using SOHCAHTOA. Now, what we're going to be finding is we're going to be trying to figure out a missing angle. So we would use this before to find like a side length, right? Like the sine of 40 equals x over 20 or something like that, right? Now we're shifting a little bit. We're just trying to get theta, get this angle by itself. How do we do that? So what we're doing is we're taking the inverse operation to both sides. So in this first one, it's the inverse sine. So that becomes the inverse sine of opposite over hypotenuse is going to give us then theta, right? Because those would cancel out. So we're left with theta. So again, our goal with inverse trig functions is to find theta. We're finding the angle measurement is when we're using these. Okay, let's look at an example. I've got it written out here, but we're not going to really need it. I'm going to show you why. All right, so what's happening here? We've got this question mark. I'm going to label it as theta because we need it to have a label. I don't like leaving it as a question mark. So it's some unknown. We'll say theta. And we know we're going to use trig ratios. Let's write out SOHCAHTOA. SOHCAHTOA. And now what are they giving us? So again, we've got our flashlight in the corner. It shines its light. So pretty, so beautiful. Across, this is the opposite side. This would be the hypotenuse because it's across from the 90-degree angle. So that leaves us with this one that's adjacent. So we're looking for adjacent and opposite tangent. So the tangent of this unknown of theta is equal to the adjacent, TOA, equal to opposite over adjacent. That's why we go slow. All right, and now we want to get theta by itself. We need to know what this angle measurement is equal to, even though I had no text on this slide telling you what our goal was. Maybe it's for the best that this is a recording then. So theta is what we're trying to find, this angle measurement. All we've got were the sides, but we can do this. We've got enough information. So now what we're trying to do is we're like, oh man, if only we could get rid of this tangent, right? We're probably thinking of dividing it from both sides because we're like, maybe it looks like it's being multiplied, but it's not. Trig functions are like their own separate thing. So the way that we can get rid of this is doing the inverse tangent of both sides of the equation. Inverse tangent. Inverse tangent of tangent will cancel. We'll be left now with theta equals, and we're going to rewrite this. Theta equals the inverse tangent of 35 over 65. Calculator. Let's check. So we're going to go to function, inverse tangent, go back to mean, of 35 divided by 65. We get theta is equal to whole number, 28 degrees. Hooray! If we were in class, I'd have you add this to your notes, but this is a recording, so we will circle back to adding this to our notes. But there we go. That's how we get theta. All right. Brain break. If you need to rest, set a timer on your phone for 2 minutes, take a break. All right. And I'd like you then, after your break, try this next one on your own. Given triangle KIP, find the measure of angle I. Round your answer to the nearest hundredth of a degree. Hundredth of a degree. All right, so again, I encourage you to pause the video, try this on your own. All right, assuming you have answers that you want checked, so you've got your work, let's see. So unknown, theta, beta, alpha, whatever you want to do. let's do something different. Let's call it beta just to be fancy because we learned it earlier and now we're gonna use it here. So what's going on? We want to find this angle. What are we given? Okay, so let's highlight. We're gonna shine our flashlight and we can label this is the opposite side. And we're also given the hypotenuse. So for sol, ka, toa, opposite and hypotenuse is going to be sine. So the sine of this unknown, beta, is equal to the opposite, 8, divided by the hypotenuse, which is 10. And again, our goal here is to get beta by itself. So how could we do this? Inverse operation. So we're going to take the inverse function, the inverse sine, to both sides. Because if we do to one side of the equation, it has to be done to the other. Inverse sine of sine, they cancel, which was our goal all along. So we get beta is equal to the inverse sine of 8/10. And we will again plug that in a calculator. So we'll go to function inverse sine of 8 divided by 10, and we'll get beta is equal to 53 degrees. So if you also got that, nice, pat on the back. If we didn't, I hope that looking this over kind of helps us get a start at least of what we can do, what we should have done, how we can get there. All right, inverse trig functions. All right, I was gonna have you work with a partner. This is a recording, so that's a little difficult. So if there is still time, try this on your own. I will put the answer key below so you can check your answer. And then I have this one for you on your own as well. If there is time, but I think I'll work it out and put the answer below. All right, and then on our last slide, another error analysis. I feel like this was from, yes, the last class period. I'll double check. If it's not, it'll stay there on your end and you'll see the answer too. All right, jumping to our very last slide, exit ticket. Go ahead and let me know in your Desmos, how confident are you feeling with this topic of inverse trig functions? Let me know. Don't put your question here if you do have a question, because this is a recording. We're not in class right now, so go ahead and send it in the Canvas inbox if you do have a question. All right, that's all. Bye, guys.